Let's talk about a part of your car you've probably never even thought about. But here's the thing. Without it, the modern front-wheel drive car simply wouldn't exist. Okay, let's dive into the hidden genius of the constant velocity joint, or CV joint. You know, if you've ever been in a car that makes that rhythmic click, click, click sound when you make a sharp turn, well, you've already met our topic for today. That sound, that's a cry for help from one of the absolute hardest working parts on your entire vehicle. So, what's the big deal here? Well, for engineers trying to create a front-wheel drive car, the challenge was just immense. I mean, think about it. They had to figure out how to get power from the engine to the front wheels that not only have to spin, but also have to steer left and right and bounce up and down with the suspension. A simple solid axle? No way that was going to work. So you might be thinking, well, why didn't they just use a universal joint, a U-joint? Great question. Turns out it fails pretty miserably in this role. A U-joint is fine for a drive shaft on a rear-wheel drive car, but the second you angle it sharply, you create a huge problem. The output shaft starts speeding up and slowing down with every single rotation, even if the engine speed is constant. At the sharp angles you need for steering, this causes just terrible, violent vibrations. And just think about the scale of this problem. The outer joint, the one right there by your wheel, it has to smoothly handle angles of up to 50 degrees. That's what happens when you crank your steering wheel all the way to one side. A U-joint just can't cope with that, so a different kind of genius was needed. This huge problem led to an incredibly elegant solution, one that literally changed the shape of the modern car. The answer was a joint that could maintain what they called constant velocity. And really, the name says it all. A constant velocity joint is engineered to do one thing perfectly. Make sure the wheel turns at the exact same speed as the axle coming from the transmission, no matter what angle the joint is at. No speed-ups, no slowdowns, no vibrations. Just perfectly smooth, consistent power. And you know what's wild? This isn't some new technology. The most common design, the Rzeppa joint, was invented all the way back in 1920 by an engineer named Alfred Rzeppa. Now, it took decades for front-wheel drive to really catch on because of costs and other issues, but his design was so fundamentally sound that the same basic principle is still being used in millions of cars driving on the road right now. So, how does this little mechanical marvel actually pull off this constant velocity trick? All right, let's take a peek inside and look at the precision parts that make the Rzeppa-style joint tick. So when you see it all laid out like this, you can see the key players. You've got the outer housing, an inner race, a cage, and 6 big ball bearings. And it's all protected by that flexible rubber boot. The secret here isn't just the parts themselves, but the incredible precision with which they're all machined to work together in perfect harmony. Okay, and here is the magic. See that cage? Its job is to hold those 6 steel balls in a very specific position. It makes sure they always sit exactly in the middle of whatever angle the joint is at. By constantly splitting that angle perfectly in half, they transfer power from one side to the other without any change in speed. That's the whole secret. It's how you get that smooth torque even when the wheel is turned sharply. But for all its internal strength and its brilliant design, the CV joint has one critical vulnerability. The joint itself, all those metal parts, they're incredibly tough. But its protection? Well, that's a different story. This is its Achilles heel. The failure almost always happens in this exact sequence. It all starts with that simple rubber boot. Once it gets a tear or a crack, the special grease that's packed inside leaks out. And then the bad stuff, dirt, water, sand, gets in. That grime mixes with whatever grease is left and turns it into a gritty, abrasive paste. Basically, liquid sandpaper that just grinds away at all those precision parts. As our source material puts it so directly, once that boot is torn, the clock is ticking. The combination of lost grease and contamination will, without a doubt, quickly ruin the entire joint. It's not a matter of if, but when. So the key then is to learn how to recognize the symptoms. How does your car tell you that this internal destruction is happening? Well, thankfully, it gives you some pretty clear signals. The most famous sign, of course, is that clicking noise when you turn. That's the classic sound of a worn outer joint. You might also start to feel a vibration through the car, especially when you accelerate. If things get really bad, you'll hear a clunk when you put the car in gear. But honestly, the earliest warning sign of all is something you can see. Dark, greasy splatter on the inside of your wheel. That is a dead giveaway that the boot has failed and the damage has already begun.
Okay, so understanding the problem is one thing, but what can you actually do about it? Let's wrap this up with some practical tips on how to protect these crucial parts and save yourself a really expensive repair bill down the road. The big takeaway here is all about prevention. First and foremost, just look at the boots every once in a while. If you see a crack or a tear, get it replaced immediately. A new boot costs next to nothing compared to a whole new joint. Also, try to avoid flooring it when the steering wheel is cranked all the way over. That puts the absolute most stress on the joint. And of course, if you do need a replacement, make sure you use quality parts and the right kind of grease. So it really leaves you with a question to think about, doesn't it? This whole brilliant system, this key to modern automotive design, is entirely dependent on a simple, flexible piece of rubber. It kind of makes you wonder, is that little CV boot maybe the most important and definitely the most underrated part on your car's entire axle?